Okay, now we are going to look at indices now. We are looking at indices. Indices are just simply powers. Indices are powers, right? So, given numbers m and n, which are actually real numbers, if you have a power n times a power n, the bases are the same, the numbers are the same, but the powers are different, and you multiply, you just add the powers, right? If, in this case, the numbers are being divided, but the number is the same, different powers, you just subtract the powers. If a number is powered, but it is powered again, so like for example, this is a power m, but again power n. So we just have to multiply what? We just have to multiply the powers. Is that okay? If a number is powered by a fraction, so what we have to do is we make the denominator, it becomes the root, then the numerator becomes the power. So it becomes nth root of a power m, or it can become the nth root of a power m. It's the same thing because multiplication is commutative. Then we are also saying if you have a power a negative number, the negative just simply means you have to do the reciprocal of that number. That is a power minus m is 1 out of a power m. This also implies if the negative is on the denominator, then it means you have to do the reciprocal, then it becomes the numerator without the power. Is that okay? So this is 1 out of. So it just simply means that the negative will always mean the reciprocal of that number. Is that okay? So if you have a negative of a power, it just simply means do the reciprocal of that number. Then lastly, we are saying any number power 0, because a represents any real number. Any number power 0 will always be 1. Any number power 0 will always be 1. So we want to use the examples given here to be able to apply the laws of indices here. To be able to apply the laws of indices. So let's try to look at the solution of these numbers. The first one is 5 power 3. 5 power 3. So 5 power 3 simply means multiply 5 3 times. 5 times 5 times 5, and the answer is actually 125. 5 times 5 times 5, that is 125. Is that okay? And then number 2 is 13 power 0. Number 2 is 13 power 0. We have already said from our last law of indices that any number power 0 is always 1. So this one will be equal to, this one will be equal to 1. Then our third question is 8 power 2 out of 3. 8 power 2 out of 3. Remember we have said if you have a power which is a fraction, the denominator becomes the root, the numerator remains the power. Is that okay? The denominator becomes the root. So this is the cube root of 8 power 2. Is that okay? So that becomes the cube root of 8 power 2. But remember we have said this squared can even come inside. And it can come inside and becomes the cube root of 8 squared. Is that okay? But now here, if you look at this one, in that case, it will become the cube root of 8 is 2. So this is 2 squared, which is actually 4. So that's what we have there. Then our fourth is 16 power negative 3 out of 4. Our fourth is 16 power minus 3 out of 4. Is that okay? So before we did in form of a cube, a root and a power. Let's first deal with the negative, whereby I have said the negative causes the number to become its own reciprocal. So it will become 16 power 3 out of 4. So in that case, the root disappears. The negative disappears because its meaning is the reciprocal there. So if the root disappears, so what we have now is going to be the fourth root of 16 power 3. So this is the fourth root of 16 power 3. The fourth root of 16. This is the fourth root of 16. The fourth root of 16 power 3. Fourth root of 16 power 3. But the fourth root of 16 is actually 2. The fourth root of 16 is actually 2. If you don't remember how to do the fourth root, you can always use the factor tree. I don't know if you remember the factor tree. Where you just keep dividing 16 by its what? By its first prime number, or by its first factor. If I'm to remind you, whatever, by 16, 8, by 2, 4, by 2, 2, by 2, 1. That means 16 is the same as 2 power 4. So if you take the fourth root both sides, you'll actually appreciate that the fourth root of 16 is 2, so that becomes 2 power 3, which is actually 1 out of 8, which is actually 1 out of 8. So that is it. If you look at Roman 5, we have x power 5 times x power minus 3, and x power minus 3. Remember what we said? We said that if you are multiplying same bases but different powers, what you have to do is to add the powers. In that case, so here we have the same base, x, so we're just going to add the power. So this is the same as x power 5 plus minus 3, which is actually x squared. Because 5 plus minus 3 is actually 5 minus 3, which is actually x squared. Then our last simplification, we have x power 5 in power 3 divided by 8x power 4. We have x power 5, then still power 3, then minus divided by 8x power 4. I want to simplify this now. So the first thing we are going to deal with is the fact that if you have a number that has a power, but it is powered again by another power, we have to multiply the powers there. So in that case, this is going to be x power 5 times 3. That is going to be x power 5 times 3. If the powers are powering each other, you just multiply it. Divide by 8x power 4. Is that okay? This one becomes x power 15 divided by 8x power 4. 8x power 4. So in that case, I can represent the division sign with a long line. So it becomes x power 15 over 8x power 4. Such that in that case, I can compare x and x in terms of division. Is that okay? So it means this one is going to be 1 over 8. Now x divided by x, same base. So I subtract the powers. So it shall be x power 15 minus 4. 15 minus 4. And actually the answer will become 1 out of 8 x power 11. I cannot simplify it further than that. Is that okay? So the question, number 2 of the question. Now it says find the value of x such that 5 power x is equal to 1 out of 125. 5 power x is equal to 1 out of 125. So So number 2, Roman 1 says 5 power x is equal to 1 out of 125. How do we solve for x here? So our intention would be just to get these numbers, make sure the bases are the same. If the bases are the same, equate to the powers. Is that okay? So I'm going to make sure I express 125 in terms of 5. 125, this is 5 power x is equal to 1 over 125 is the same as 5 cubed. 125 is the same as 5 cubed. Is that okay? But now the bases are not the same. This is a reciprocal. I mean, this is a denominator, this is a numerator. You cannot compare them. So what you have to do, I can make this one go up by attaching the negative there. If you remember that law of logarithm. So I mean of indices. So x power 5 power x becomes 5 power minus 3. The negative just implies that I have done the reciprocal. Is that okay? So this and that, they are the same. So now I have succeeded in making sure the bases are the same. This is 5, this is 5. So since the bases are the same, I'm just going to equate to the powers. So this implies that x is equal to minus 3. That implies that x is equal to minus 3. X is equal to minus 3. Question, we have 2, we have 3 power x times 3 power 5 out of 3 power 7 is equal to 27. Is equal to 27. So we want to solve this one. So in order to solve it, you have to make sure the powers are the same. When the powers are the same, then you can easily compare them. I mean the bases. If the bases are the same, you can easily compare the powers. We make the bases the same because x is in the power. Okay? So if you want to do that, then these ones are the same and this one is different. But we know that 27 is 3 power 3. So in this case, this will be 3. When I'm multiplying, I add, so it will be x plus 5. I am adding. Is that okay? Out of 3 power 7, this one is equal to, this is 3 power 3. 27 is 3 power 3. But also remember, since I'm dividing, the bases are the same. I just subtract the power. So this one will be 3 power x plus 5 minus 7. Minus 7. And this one is equal to, that is 3 power what? 3 power 3. So since the bases are the same, I'm going to equate to the powers. So if I'm to equate to the power, this will be x minus 2 is equal to 3. That will be x minus 2 is equal to 3. If I put 2 beside, x is going to be equal to what? 5. X is going to be equal to 5. So these numbers are so then now we have that one. Now this third one is a bit tricky and we need to pay close attention to each. Now this is 2. This is 2 power 2 into x plus 1. X plus 1 minus 5 into 2 power x and then plus 1 is equal to 0. In this case, we have to look at it carefully. If you look at it carefully, you realize that it looks more like a quadratic equation. But we need to now convert it to a quadratic equation. So in that case, I need to at least make 2 power x become the variable of the equation. So I need to find a way of making 2 power x, of coming up with 2 power x here. So when you look at this, if I try to expand this, only this, it will be 2 power 2x plus 2, then minus 5 into 2 power x, then plus 1 is equal to 0. This one now, applying the first law of logarithm, if I am adding bases, if I'm adding powers, I mean, I'm going to multiply the bases. This is what I'm talking about. That if you have a power n plus n, I can split this and it becomes a power m times a power n. Is that okay? So applying it here, this would be 2 power 2x times 2 power 2. 2 power 2x, right? Times 2 power 2. Then minus 5 into 2 power x plus 1 is equal to 0. This is 4 now. This is 4. So it will be 4 into, now this is 2 power 2x. This is the multiplication of powers. But you have to remember, for multiplication of powers, you say, if you are multiplying the powers, you can bring 1 in the bracket, it becomes a power n, then power n. But remember, multiplication is commutative. That means it can also be a power n, then brackets power n. Remember, I'm trying to isolate 2 power x. I'm trying to isolate 2 power x. So in this case, this is 4 which is here. Now this 2 power 2x can be 2 power x, then power 2. You appreciate that 2 power 2x is the same as 2 power x, then power 2. Which is the same actually as 2 power 2, then power x. But since multiplication is commutative, I can bring x inside. Is that okay? Then minus 5 into 2 power x, then plus 1 is equal to 6. So in this case, I have isolated 2 power x from that expression. So I can let 2 power x be equal to 1. You can call it any other name, but I have chosen 1. So in that case, I have 4y squared minus 5y plus 1. This one is equal to 0. Is that okay? So in this case, I need to solve the quadratic equation. Which quadratic equation shall help me to get the value of y, and then y I can substitute here to get the value of x. Then I will have solved the equation. So in this case, we are going to sort of have this equation, whereby in this case we need to get 2 numbers whose multiplication will give us 4 times 1 4, and its addition will give us minus 5. Those numbers are actually minus 4 and minus 1. So I'm going to replace minus 5 with minus 5 minus 1. So this one is going to become 4y squared minus 4y minus y plus 1 is equal to 0. If I factorize, this one will become 4y into, here remaining y, here remaining minus 1. If I factorize out negative, minus into, this will be y, this will be minus 1. This one is equal to 0. Further factorization, I pull out y minus 1, y minus 1. I remain here with 4y, I remain here with 1 minus 1 is equal to 0. So in that case, I will end up with either, because if you have 2 brackets equating to 0, one of them should be 0, otherwise it will not make sense. So either y is equal to 1, I mean either y minus 1 is equal to 0, implying that y is equal to 1, or 4y minus 1. 4y minus 1 is equal to 0, which implies that y is actually a odd 1 out of 4. Because this one goes this side, then you divide both sides by 4. Is that okay? But the question does not want y. I am the one who invented y. What's the value of y? According to my statement, 2 power x is 1. Is that okay? So case 1, when y when y is equal to 1, what will be the value of x? What will be the value of x? So I'll have 2 power x. 2 power x is equal to 1. Remember what we said. We said if you want to solve where in this case the power is the one needed, you have to make sure that the denominators are the same. I mean the bases are the same. But now how do I make this to have the same base as this? The base is 2. I have to apply minus law. Whereby I said to get 1, I just need to get any number or 0. So it means I can apply that by saying that 1 is the same as 2 power 0. Is that okay? So this will imply that 2 power x is equal to 2 power 0. 2 power x is equal to 2 power 0. What would that give me? That will give me the fact that now x is equal to 0. This implies that x is equal to 0. Is that okay? However, you can also apply logarithm. Like for example, in case 2, let's see what will happen if I apply logarithm in case 2, whereby I'm now using y as a quarter. So I have 2 power x is equal to 2 power x is equal to a quarter. 2 power x is equal to a quarter. Is that okay? Of course, I can express a quarter in terms of 2. But now, instead of using this, let me try to apply logarithm so that you can understand. But if I was going to apply logarithm, 4 is the 2 power 2. So I would have 1 out of 2 power 2, which would actually be 2 power minus 2. Is that okay? But if I would apply logarithm, I apply logarithm to base 10 both sides. 2 power x is equal to log of a quarter. Base 10. If you have to apply logarithm, it would be better to apply to base 10. After the lot of logarithm, the x will come behind, and so it will become x log 2 base 10 is equal to log of a quarter base 10. Log of a quarter base 10. So x is going to be this divided by that. So in that case, x is equal to log of a quarter base 10 out of log of 2 base 10. So this one we are going to apply our calculator to get the answer. We're going to apply the calculator to get the answer. Minus. So that is it. Let's look at our last example here. Our last example here. 3 power 2y minus 3 power y plus 1, then minus 3 power y plus 3. That is our first question. It says 3 power 2y, then minus 3 power y plus 1, then minus 3 power y, then plus 3 is equal to 0. Plus 3 is equal to 0. Also, when you look at this one also can be represented as a what? It can be represented as a quadratic function, whereby we are going to make our variable 3 power 1. Is that okay? So I'm going to make sure I create 3 power 1 everywhere. So this one still can be 3 power y, then power 2. I hope you appreciate that. Is that okay? Then minus, now this one, I'm applying the first law of indices, whereby if I am adding the powers, this will be 3 power y times 3 power 1. Is that okay? That will be 3 power y times 3 power 1. This one is already minus 3 power 1, then plus 3 is equal to 0. Now this will be 3 power y squared minus 3 into 3 power y, then minus 3 power y plus 3 is equal to 0. Is that okay? So I can let 3 power y to be let 3 power y, let 3 power y be, let 3 power y be, I can call it m. Let me call it m. Is that okay? So in this case, this will be m squared minus, this is minus 3m. Minus 3m. Then this is minus m. Then plus 3. This is equal to 0. Plus 3. That one is equal to 0. This will give me 4m. Is that okay? That will give me 4m. So I will have m squared minus 4m. Then plus 3. This one is equal to 0. So I'm going to look for numbers with numbers such that when I add them, I get minus 4. I multiply them, I get 3. And those numbers are minus 3 and minus 1. Is that okay? So this one will be m squared minus m minus 3m. Then plus 3. This one is equal to 0. If I factorize here m, I remain with m minus 1. Right? Factorize out here minus 3. I remain here with m. Here I remain with minus 1 is equal to 0. Minus 1 is equal to 0. Then I further factorize m minus 1 into here I remain with m. Here minus 3. This one is equal to 0. Either m minus 1 is equal to 0, which implies that m is 1, or m minus 3 is equal to 0, implying that m is equal to 3. M is equal to 3. So I am going to use this to get the value of y. That's 1. When m is equal to 1, remember I have said let 3 power y be m. So in that case I have 3 power y is equal to 1. But just like I did the other side, any number power 0 is 1. So in that case 3 I can make it 3 power 0. So this will be 3 power y is equal to 3 power 0. This implies if I equate the powers alone, y is equal to 0. Y is equal to 0. What about if m is 3? If m is 3, case 2. M is equal to 3. That means 3 power y is equal to 3. Is that okay? So if it is just 3, it means it is 3 power 1. Is that okay? So that means it is 3 power 1 such that y is equal to 1. So in that case, y1 is 0 and y2 is actually 1. So this is how we solve indices. This is how we solve